Hello everyone, I hope you all are fine. So today we are going to understand the term diffusion. So what is diffusion? Actually the spreading out and the mixing of substance with another substance due to motion of its particle is called diffusion. Right? Now I'll explain you this with the help of one activity. Here we have taken two jars. In first jar we have kept bromine vapor. So here it is one jar, and in this jar we have kept bromine vapor, and here it is the another jar in which we have kept the air only, and we have inverted this jar on the first jar. Now after some time what will happen? The particles of the bromine vapor will move upward and will go and mix with the air which is in another jar, and after some time we will see that this jar will become red brown, and this is actually happening due to the diffusion, because what I have told you that diffusion is the intermixing of particles. Now let us see the diagram. In this jar there was the bromine vapor that was of red brown color, and in this jar there was the air, and air is colorless. And now we have inverted this is first jar, this is second jar on the first jar, and what will happen now? The air will start moving from here to here, second jar to first jar, and the bromine vapors will start moving from here to here, and after some time this bromine vapors will diffuse with the air, and both the jars will become red brown in color. Now students, think that as the bromine vapor is moving from here to here, then what about air? Is air moving from here to here or not? Yes, actually air is also moving from upper jar to lower jar, right? But we cannot see it because air is colorless. Diffusion is the property of matter which is based on the motion of particles. Why I am speaking like this? Because if these particles will not move, and if these particles will not show motion, then why these particles will go in this jar? Then how the particles will go in this jar? Actually, the movement of particles is occurring, that's why the diffusion is happening, right? That means when the movement of particles will more, diffusion of the particles will more. And when will be the movement of particles more? When the force of attraction between the particle is less, or the distance between the particle is more. So, diffusion is fastest in gases, because in gases there is a very weak force of attraction between the particles, and there is very large space between the particles. Then what will happen? The particles are more free to move. That's why the diffusion will be very fast in the gases, and diffusion will be very slow in the solids, because as I told you earlier also, solids are very closely packed and the force of attraction between the particle is very strong. Then they are not as much free to move. And this phenomena of diffusion also explains us that the particles of the matter move. And here I will explain that if we increase the temperature, or on increasing the temperature, the rate of diffusion also increases, because when we are increasing the temperature, particles are getting heat and they are getting energy, then they will start moving fast. And when they will start moving fast, then they will start doing the fast diffusion. So that's all about the diffusion. Now let us understand the cases of diffusion. Now let's see the examples of diffusion from our daily life. We all know that we can smell the food being cooked in the kitchen, and that reaches us even from the considerable distance. When the food is cooking in the kitchen, then also you can experience the smell of the food. So when the food is cooked, some of the substance in food release gases, because when we are cooking the food, then some of the substance releases the gases, and the particles of these gases moves very quickly and mix up with the air by the diffusion. And when the air containing these gases reaches our nose, we can get the smell of food being cooked in the kitchen, right? So when we are cooking the food, it is releasing some gases, and these gases are getting mixed with the air, and with the air, these gases are coming to our nose. Now let's see the another example, and the example is we can we can smell the fragrance of burning incense stick. Okay, that is also due to the process of diffusion, because when the incense stick is burning, it is producing some gases having the fragrance, and when these gases mix with the air, then with air it reaches to our nose. And now think about the perfumes. When we are opening the bottles of perfumes, from perfumes, some special kind of gases or vapors, perfume vapors, come out in the air due to the process of diffusion. And when this perfume vapors reaches to our nose with the air, we can smell the fragrance of the perfume very easily. Now think about the LPG. When there is a leakage of cooking gas LPG in our homes, it is also, we are detecting it with the process of diffusion only, because LPG gas is coming out from the cylinder and it is mixing with the air present in the room or present in the home, then it is reaching to our nose, then we can identify it. So now it was about the diffusion in gases. Now we will see the diffusion in liquids. Diffusion in liquids is slower than that in gases, because the particles of the liquids move slowly as compared to the particles of gases. Now let's see some of the examples. When we are putting a drop of ink into the beaker of water, then the color of ink spreads into the whole water of the beaker, because the spreading of the ink in water on its own is due to the diffusion of ink particles into the water. Now we will see diffusion in solids. So does the diffusion happen in solid? Yes, diffusion is also occurring in the solids also, but the rate of diffusion in solid is very slow. Then let us see some examples. When we write something on blackboard and we leave it unclean for the considerable time, for the long time, then we find that it becomes quite difficult to clean the blackboard, right? This is due to the fact that because board has another kind of particles and chalk has another kind of particles, so this is happening due to the fact that chalk have diffused into the surface of blackboard, because the chalk particles has diffused with the particles of the blackboard. So that's all about the diffusion. Finally, we concluded that the diffusion is fastest in gases, then it is less faster than gases in liquid, and it is very slow in case of solids. Now the next topic is some common units of temperature and SI unit of temperature. Actually, Andrew Celsius, the name of scientist, right, who has invented the Celsius scale temperature, and here is the picture of Lord Williams Thomson Kelvin, scientist who has invented the Kelvin scale of temperature. In general, in common, we use the Celsius scale of temperature in our daily life. So what is the common unit of temperature? The common unit of temperature is degree Celsius and is written as like this, degree Celsius, and read as degree Celsius, right? and the melting point of the Celsius scale of temperature is 0 degree Celsius, and the boiling point of water on Celsius scale is 100 degree Celsius. And there is another scale of temperature called Kelvin scale, and which is used in scientific calculations and for the research work. The SI unit of measuring temperature is Kelvin. So what is the common unit? Common unit is degree Celsius, and the SI unit is Kelvin, and which is denoted by the capital K. And as we were writing degree Celsius in Celsius temperature, we will not write that this one sign here in Kelvin temperature, right? What is the advantage of Kelvin temperature? Celsius temperature can be 0, but this Kelvin temperature is always positive, and this scale, Kelvin scale is always positive. The melting point of ice is on Kelvin scale is 273 Kelvin, and the boiling point of water on Kelvin scale is 373 Kelvin. Now let's see the relationship between the degree Celsius and the Kelvin temperature scale. 0 degree Celsius is equals to 273 Kelvin. So temperature on Kelvin scale will be always temperature on degree Celsius scale plus 273. If you have to find out the temperature in Kelvin, then you have to write the temperature in degree Celsius and then you will add 273. And when you have to find out the temperature in degree Celsius, then you will minus 273 from the Kelvin temperature. Now let's see some questions here. Convert the temperature of 25 degrees Celsius to the Kelvin scale. Here the temperature is given in degrees Celsius and we have to convert it into the Kelvin scale. So temperature on Kelvin scale we will find out with the help of this formula, temperature on Celsius scale plus 273. So here we will write temperature on Kelvin scale is equal to temperature on Celsius scale plus 273. What was the temperature on Celsius scale? 25. And what we will add after that? 273. Now the answer is 298 Kelvin. So thus the temperature of 25 degrees Celsius on Celsius scale is equals to the 298 Kelvin on the Kelvin scale.